Hello everyone, this is Firdous Mir and today I will be solving a question that has been asked in JEE Advanced 2024, which is in the chemical kinetics, as this subject chemistry relates to my expertise. So the question here is given as: consider the following reaction. It's a reaction. This is the overall the reaction. Twice hydrogen gas plus twice NO gas gives N2 gas plus twice H2O gas, which follows the mechanism as it is multi-step reaction. This was the overall reaction, and these are the multiple steps involved in this. So the first step is so the first step here is twice NO gas gives N2O2. This one is equilibrated step. That means it's going forward in direction as well as in backward direction. The forward direction rate constant here is given K1, and the backward direction one is given K minus 1. And it is mentioned here fast equilibrium. So the second step is N2O2 gas plus H2O gas gives N2O gas plus H2O gas. And the rate constant involved here is K2, and this step is slowest step. That means it is RDS, rate determining step. And the third step is N2O gas plus H2 gas gives N2 gas plus H2O gas. It's a fast step as well, and the rate constant mentioned here is K3. So this one is complex reaction. So in elementary reactions, we directly correlate stoichiometric coefficients with the order. But here, reactions which involve complex steps or multiple steps, we can't directly go by that method. So in such cases, we use two approximations. The first one is steady state approximation, and the other approximation is equilibrium approximation. As here it is given as fast equilibrium, that means we will be using equilibrium approximation. So it's a condition for using equilibrium approximation. When we have complex reaction involved, there is given as fast equilibrium equilibrated step. That means we'll be using fast equilibrium approximation in order to divide the rate or order of the reaction. So in complex reaction, we directly write our rate of the reaction by using RTS or rate determining step. As to find the order of the reaction, we rely on the slowest step, that is our rate determining step. So here the rate determining step is this step, that is our second step. This step, that's our second step. So I will be writing rate expression as this step. The rate expression or the rate will be equal K2 because as here I'm writing rate expression in terms of the reactive species involving reactants here. So but here N2O2 is intermediate. We don't want our intermediate to be in our overall the rate expression. So in order to calculate the concentration of intermediate here, because intermediates are short-lived, that's why we don't want to devise their exact concentration is very difficult. So as they are short-lived, so we will be using here the equilibrium step in order to reduce the concentration of N2O2 here. So using that step, I will be writing K equilibrium, that is K forward upon K backward, write as K forward, that is K1 upon K backward, that is K minus 1, will be equal N2O2 upon NO square. This is our equilibrium step. As I write here, as I wrote here, equilibrium constant for this reaction. So the concentration of N2O2 will be here as it was in denominator. यहाँ पे numerator में चला जाएगा. That means K equilibrium into NO square. अब ये जो concentration हमारी निकली as an intermediate की, सो इसको हम पुट करेंगे इस वाली फाइनल रेट एक्सप्रेशन में. सो रेट विल बी इक्वल्ड K2 by N2O2. I will be doing this K equilibrium square. So now this is our final rate expression जिसमें intermediate है ही नहीं. So now we can just directly go by adding the powers of these reacting species. So that will be our order of the reaction. That means order will be 2 plus 1 equal to 3. Overall order will be 2 plus 1 equal to 3. But the order with respect to NO will be second order, and with respect to hydrogen, it will be first order. That means with respect to hydrogen, H2, it will be first order reaction, and with respect to NO, it will be second order reaction. And the overall order of this reaction is 3. So thank you so much. It was the complete solution of this question.